question 11. A school is creating a 4-digit student code system. For security reasons, the code cannot start with an even number. How many codes are possible? On this paper, MathsCounts 2000, there are 2 questions that you could consider to be pigeonhole problems. So if these are ones that you often have questions about, if you're not sure, you get stuck on, then you might want to Google pigeonhole problems. But I'll have a go in answering question 11 and question 4, which is the other one, to give you an idea about what you need to do with these questions. This one on the paper I find the more straightforward. Let me show you. So a school is creating a 4-digit code system. So here are my 4 digits. For security reasons, it says the code cannot start with an even number. So the numbers that this could be are the digits that this can be are 1, 3, 5, 7, and 9. These are the only possibilities that this digit can be. So in total, you have 5 possibilities. 1, 2, 3, 4, 5. You have 5 possibilities. Now, what you choose here is not dependent on what you chose here. So you could have like a 1 and a 1 and a 1 and a 1. You could have a 1, a 3, a 1, a 3. You could have a 1, a 2, 7, 9. You could have all sorts of different combinations. But the first digit is we have 5 possibilities. Because we can have any digit at all for the second. So we can have 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. We actually have 10 possibilities here. The same for this one because there's no restriction, and the same for this one, which means there's no restriction as well. So the total combinations, the total number of combinations are 5 ways of putting it here, and we multiply it by the 10 ways we've got here, the 10 ways we've got here, and the 10 ways we've got here. So let me just check my worked examples and make sure I got this right. Yes, I have. We take 5 multiplied by 10, 100, 1,000 gets me 5,000 possibilities. What goes here? How many different ways can I fill this space here? 5. How many different ways can I fill this space? 10, 10, and 10. And then with these pigeonhole problems, you use multiplication to get to the answer. Take a look, have a watch of my question 3. Let me just check it is 3 while I'm here. No, question 4. So question 4 is similar. So question 4, also question 4 on this paper. Okay, so once you had a look at this, hop over to question 4 and see a more complex example.